Okay, so this is the pre-lab video on the solar insolation of the Earth lab that we're going to be doing here. And so we have it here. Let me go to the lab here. So here's the solar insolation of the Earth. Um, so what we're going to be doing is basically simulating the Earth, receiving light because the Earth is a sphere. As light hits it directly, as you move away from the equator, the amount of energy sort of per unit of area decreases, and that's essentially why it's colder at the poles and warmer at the equators. So we're going to just prove that is in fact true. So what you're going to need is you're going to need several pieces of paper. I would grab probably 2 or 3 just in case pieces of paper. You're going to need a protractor, a pencil, probably an unsharpened pencil. I have a bunch of them, and then some masking tape, some scissors, a ruler. A couple other things there on the materials list. So basically, you're going to tape your pencil to your ruler. So looks just like this. So I've sort of, hopefully yours will look better. I try to do this like by myself, but when you're with a partner, you're going to tape this to the flashlight. So you have a nice straight edge there. This is going to help you find your angles. So you're going to tape it just like that. And so it should work out with 2 people. You're going to need a protractor, some form of protractor. You're going to need a calculator as well, probably a graphing calculator if you have one. If not, I got a couple of those. But basically what you're going to do is, the procedure tells you, is you're going to cut out a square, a 10 centimeter square, just like this. This is really doesn't have any use in the lab, but it's going to help you create a conversion formula as we go to, as you see here, as we convert mass into area and then ultimately into the amount of energy per area. So you're going to cut out a little 10 square meter or 10 centimeter by 10 centimeter square, and then you're going to use it on an electronic balance, electronic scale, and you're going to measure the mass of this. So then you're going to go through and you're going to put your pencil on paper. So it's not this paper, but the other pieces of paper you have, and you're going to put the flashlight on this at whatever angle it says on the data table. At first it's 90 degrees, so it's just straight up and down, and then you're going to then tilt it as you go through the data table. Now when you go to the directions, say you're going to trace the brightest spot of the light. And so you're going to want to do probably literally the brightest spot. It's going to be a small area at first. I think my 90 degree here, let me see if I can find my 90 degree, is pretty small. And then as you do tilt the angle, you'll see that these ellipses get a lot bigger and then ultimately really big. But you're going to then weigh them and put those in their mass here, and then use your conversion that you created up here to convert to be able to find the area, because it's really hard to find the area of an ellipse. And so if you have a conversion, you can do it pretty easily, and then you'll find the energy per area. Once you get over here to this side, you're going to get some really big numbers. So I would refrain probably from using decimals. Just keep it easy and just round to the nearest whole number, and that'll make it easy. But for the area, you're going to obviously need decimals because these are really small, and we're talking meters squared. So you're definitely going to need some decimals there. I would go out at least 4 or 5 decimal places in this middle column here. And then what you're going to do once you have the data table complete is you're going to go through and you're going to go to in your TI, whatever, you can go on any graphing calculator, and you're going to put it in the stat plot to create a linear regression model, find the slope and then the equation, and then just see how well that correlates. If for some reason you do the linear regression and you don't see your R, let me know or somebody know. But you basically need to go to your diagnostics and turn on your stat diagnostics, and then the R will start to appear there. If you have any questions, let me know about that. And then basically, you're going to go through and see how the amount of energy per unit is affected as you go up towards the poles. The goal here is to see how, as you move up in latitude in the Earth, how the amount of energy is affected as you move up the latitude or in latitudes of the Earth. And that's sort of the point here. And you're going to basically mathematically proving it. So I hope this pre-lab video helps. Read the directions. One of the things I would definitely do before you start, and I'll remind you of this, is to watch the first link in the resources for this chapter. If you go to Unit 5 in Canvas, you'll see several videos. It's also in your notes guide. But the first video by Bozeman Science called The Atmosphere, that'll really sort of help out as you're doing your analysis at the end. If you can watch that video, you'll really understand why this happens. So, hope it helps. Thanks.